When you type a question into ChatGPT, nothing looks up the answer. There is no database of facts behind the screen and no list of rules deciding what to say. The model does exactly one thing, over and over, billions of calculations at a time. It predicts the next word. That is the whole trick. It reads everything written so far and asks, what word is most likely to come next? Then it asks again and again and again. Every essay it writes, every bug it fixes, every fact it appears to know comes out of that single move repeated at enormous speed. How one trick turns into all of that is a genuinely strange story, and it starts with a surprise. The model never sees words at all. Text goes in as tokens. Before the model touches your question, a separate step chops your text into small chunks. A token is usually a common word, or a piece of a longer one. The sentence the robot painted a picture splits neatly, one token per word. But a rarer word like unbelievable gets broken into pieces. Able. 3 tokens for one word. Then comes the strange part. Each token is swapped for a number, its ID in a fixed vocabulary of roughly 100,000 entries. The word might be token 464. Robot might be token 9379. By the time your question reaches the model, every trace of language is gone. What arrives is a list of numbers, nothing more. The model has never seen a letter in its life. And what it sends back is not a sentence either. It is one enormous set of scores. Here is the model's entire job. Given the tokens so far, it produces a score for every token in its vocabulary, all 100,000 of them at once, saying how likely each one is to come next. Feed it the cat sat on and the scores form a ranked list. Mat might get 46%, floor, 21%, couch, 9%, table, bed, and sofa take smaller shares, and far down the list, a token like submarine sits near 0. Look closely at what this list really is. It is not a fact about the world. It is a claim about text. Given everything people have written, this is how sentences like this one tend to continue. Every question you ask, however deep, gets answered by exactly this kind of list, which leaves an obvious problem. A list of odds is not an answer. Something still has to pick. The picking happens one token at a time, in a loop. The model reads your prompt, produces its ranked list, and one token is chosen from near the top. That token is attached to the end of the text. Then the whole thing runs again, with the slightly longer text as input, and a fresh list appears. Another token is chosen, attached, and around it goes. Watch it build a sentence. The cat sat on It picks Matt. Run again, and the next pick is a period. Then it picks the word it, then looked, then comfortable. There is no plan for the paragraph, and no outline of the argument. The model decides each word only when it arrives there. The way your phone keyboard suggests the next word, just enormously better at it. Which raises the real question, how did it get this good? The answer is practice, on trillions of words. Training works like an endless quiz. Take a real sentence from the internet, hide the last word, and make the model guess. Paris is the capital of. Suppose the young model guesses Germany. The training program compares that guess with the real answer, France, and measures exactly how wrong it was. Now the crucial step. Inside the model sit billions of adjustable numbers called weights. Think of them as tiny dials. After every wrong guess, each dial is nudged a tiny amount, in the direction that would have made France more likely and Germany less. One nudge changes almost nothing. But this loop runs on trillions of words, sentence after sentence, for months. Slowly the dials settle into values that guess well. And notice what that means. Grammar, facts, writing style, even code, all of it ends up stored as nothing but dial settings. There is no file of facts anywhere in the machine. The knowledge is the weights. One more invention was needed, though, before this could handle whole essays, the model had to learn where to look. Predicting the next word often hinges on one specific earlier word. Take the sentence "The cat chased the dog because it was angry." To continue sensibly, the model must figure out what the word it refers to. Attention is the mechanism that does this. As each new token is processed, it looks back at every earlier token and gives each one a relevant score. How much do you matter to me right now? Here, The word it pulls hard on the cat, pulls a little on the dog, and barely notices small words like because. Those pulls decide which information flows forward into the next prediction. This idea was the breakthrough that made modern language models possible. The design built around it, published in 2017, is called the transformer, and it is the T in GPT. So attention explains how the model uses context. It does not explain something you have probably noticed. Ask the same question twice, and the answers come back different. The model does not always take the top token. When it picks, it samples from the list. Usually the likeliest token, sometimes the second or third, occasionally a long shot. A setting called temperature controls how adventurous the picks are. Turn the temperature down near zero, and the model almost always takes the number one choice. So answers come out consistent, safe, and a little repetitive. Turn it up, and lower-ranked tokens win more often, so the writing gets varied, surprising, sometimes strange. Same prompt. The old house on the hill was. At low temperature you get quiet and empty. At high temperature you might get breathing. And because one early pick reshapes every list that follows, two runs drift apart word by word into completely different answers. Sampling explains the variety. It does not explain the manners. A raw predictor would not politely answer your question. It would just keep typing. A model trained only to predict is an autocomplete, not an assistant. Ask a raw model, how do I boil an egg? And a perfectly likely continuation is another question, like, and how long does it take? Because online, questions often sit in lists of other questions. So chat models get a second phase of training. The model writes several candidate replies to the same prompt, and human reviewers rank them from best to worst. Replies that are helpful, honest, and safe get marked as preferred. Replies that are evasive, rude, or dangerous get pushed down. Those rankings become a new training signal that nudges the same weights again, this time toward answers people actually want. The method is called reinforcement learning from human feedback, and it is the difference between a text predictor and something you can talk to. But it shapes behavior, not truth. A polished, helpful tone is no guarantee that the content is right. That gap has a name. Hallucination is what happens when plausible and true come apart. The model produces likely text. Ask it for a book about some obscure topic, and the most probable continuation looks exactly like a real reference. A plausible author, a plausible title, a plausible year, assembled from the patterns of a million real citations. The book may not exist, and nothing malfunctioned. The model did its one job perfectly. It continued your text in the most likely way. It has no internal marker that separates remembering from inventing, so the fluent, confident tone stays identical either way. The confidence comes from the writing style it learned, not from evidence. It is autocomplete doing its job in a place where you wanted a lookup. So the practical rule is simple. Treat the model as a brilliant drafter with an unreliable memory, and check anything that has to be right. Put the machine back together. Your words become tokens, a plain list of numbers. The model turns that list into scores for every possible next token. One gets picked, attached to the end, and the loop runs again, one token at a time, until the answer is complete. The picking is guided by weights tuned across trillions of words, focused by attention, loosened or tightened by temperature, and steered toward helpfulness by human feedback. There is no database and no rulebook, just next word prediction at colossal scale. Every essay, every explanation, every piece of code is that one engine running. One part of the story is still a black box, though. What is actually inside those billions of weights? And why does stacking simple layers create something this capable? Next time, what a neural network really is, from a single neuron up.